Okay, we're going to talk about composite centroids, and I've got a lot of stuff set up here, but first I'm going to jump back in and kind of go through where some of the stuff came from. So we're in Chapter 9, Composite Bodies. I'm in the e-text. So when we were talking about integration to find center of gravity, we used the integration of x dA over the integration of dA, or dW's. But here in composite parts, instead of integration, we're just going to add bigger chunks. So instead of taking infinitely small slices of rectangles and adding them up over the entire length, we're going to take bigger chunks when we're doing composite bodies. We'll still use rectangles, but we also use triangles and holes. Essentially what we're doing when we're determining the center of gravity is we're doing a weighted average. The first example here shows a weighted average with the length of the wire. So we have the length of the wire and we figure out where its center is, and we break it down into big pieces. So find out the length of the arc, the center of the arc, find out the length of the line, the center of the line, find out the length of the line and the center of the line. And this one's in 3D. So we've got the length, we've got X and Y and Z. So we really are going to get into this table approach to find a weighted average for this composite centroid. Okay. This second example shows a centroid of a plate. So this is taking area approach. So breaking this area down into 3 components. So the triangle and the rectangle or the square, and then taking away a rectangle. So we can have negative areas as well. So in this one, there's area 1, segment 1 and 2, and we're taking away segment 3. So segment 3 has a negative area. Also pay attention to where your X and Y coordinates are, that a negative X coordinate is required when the object is on the left side of the y-axis. All right, this one shows a more complicated geometry, but we're dealing with some densities, but still it's just that weighted average. So the goal here is going to be able to break down whatever the problem gives you into pieces so that you can load it into the table and then let the spreadsheet do the calculations for you. So I'm working with problem here it is, 964. So I'm going to work through this problem here. And I've also, one of the problems with the e-text is that it doesn't have the inside of the cover. The inside of the cover of the book does give us some information about standard shapes, but we've got an even better resource available on my courses. I've already kind of changed this, but let me show you one of the tools we have. Okay. So in my courses in the content under exam info, you have access to this beautiful set of equations. This is the statics section of the FE handbook. And the FE handbook is a handbook that's available if you take the Fundamentals of Engineering exam after your 4th year. It's got a great set of equations, okay, very concise, pretty much covers everything we need for statics. And down here we've got a really good set of shapes, areas and centroids, moments of inertia, which we'll get to next week. We got some circles and arcs, and we also have some parabolas. To be able to turn this around so we can see it better, at the bottom of the PDF, there's this little double arrow for tools, and on there you can select rotate clockwise. Okay. So I'm going to take some of these triangles, that rectangle, some of these circles, arcs, and copy some of these formulas over into my solution. Okay. So here I've got got the problem. I've got it set up, and I'm going to break this down into pieces so that I can fill it into the spreadsheet and calculate where that X bar, Y bar would be of the shaded area. So we're going to need to break this down into 4 different pieces, and there's not always a one right or wrong way to do this. Okay, so we'll break this down into the triangle section. We'll call that 1. Use this rectangle section, 2. We'll take this quarter arc, 3, and we'll take away the semicircle, 4. Okay. All right, so if I edit my spreadsheet here, we're going to have segment 1, 2, 3, and 4. Zoom in on this. So segment 1, we decide to be our triangle. So the first thing that we're going to do is set up the area. The area of this is going to be inches squared. And if I add it in here, then I don't have to add that unit throughout. So the area for that triangle shape is going to be, here's my equation, area is base height over 2. So the area for the triangle is going to equal 3 times 3 divided by 2. Since we have a base of 3 and a height of 3, we divide it by 2 for the area of the triangle. There's the area for segment 1. Okay. Segment 1 is going to have a center, and we need to tell it where that center is going to be. Okay. So this center location for segment 1, this is x tilde of 1. That comes through okay. The x tilde of 1 location is going to be, it's going to be 1/3 of the base, but the 1/3 of the base is 1 inch, and it's not located at 1 inch. So the x tilde location is going to be minus 4 inches. Okay? And that's over 3 plus another 1. The y tilde location is going to be 1 inch. Okay? So what we're doing right now is focusing on filling in this portion of the spreadsheet. Okay? We're going to have a lot more stuff going on, but right now we're just focusing on getting all of this information in. What are the areas? What are the centroids? Okay. Segment 2 is that square shape. So the area of the segment 2 is going to be 3 times 3, right? And you do have a little reminder down here that A equals base times height. And the base is 3 times 3. The x centroid location is the base over 2. The y centroid location is height over 2. So our x centroid here is minus 3 over 2 because it's on the left side of the y-axis. And the y centroid location is also 3 over 2. All right. So area 3 is the entire quarter circle out here. So we can take area of a circle and divide by 4. We could take area of a semicircle and divide it by 2. So the area here is going to equal pi times r squared, 3 squared, divided by 4. That's going to be the area of that quarter circle. The centroid location of this quarter circle is going to be, I'm going to switch back for a second, zoom in over here. Right, this y centroid location here, this is going to be the centroid of the half circle, but it's also going to be, if I take I take it and I split it in half. Those are going to be the same as the total one. And because this is symmetric across the center line, the x location is the same as the y location. Okay. So this 4a over 3 pi, that is the same as the centroid location for the quarter circle as well. In this equation sheet, it says y sub c. In our book, it's y tilde and x tilde, but they're going to be the same. They mean the same thing. So x tilde is going to be 4 times 3 divided by 3 times pi. Let's fix that. And y is going to be the same value. It's also going to be 4 times the radius of 3 divided by 3 times pi. All right. Segment 4 is the little semicircle here, and that's going to equal pi times the radius, and the radius here is 1, divided by 2. But, because we're taking it away from the entire thing, we need a negative sign. It has to be a negative area. Okay. X location, side to side, is 0. The x location is directly on the y-axis, so x location is 0, and the y location is 4 times 1 divided by 3 times pi. And there's the y location of the cutout. Now, the area here was negative because we're removing material. The x is 0, the y is positive because the shape has a centroid that's up here above the x-axis. So we don't switch all of the signs, just the area sign. Okay. I want to show you our key equations here. So when we are doing with integration, our key equation was x bar equaled integration of x tilde dA divided by the integration of dA. Okay. And that was all the little centroids in the x direction times all of the little areas. Well, here for composites, we have x bar equals the sum of all the x centroid locations times their areas of each of the pieces divided by the total area of the entire thing, or the sum of all the area pieces. So instead of integrating lots of little rectangles, we're going to take our 4 segments and multiply x tilde a, and that's going to give us this x tilde a over here. And then we're going to add up all of our areas, and we'll find x bar from summing those up. Let's clear this off, and I'll show you the spreadsheet. All right. So segment 1 was our triangle. We had an area. We had x tilde and y tilde values. So over here, all we have to do is just type in x tilde times a. And we can drag that equation down. Okay. We're also going to set up the equation for y tilde times the area of each segment and drag that equation down. For our math, right, we're going to take the sum. Okay. So we're going to sum all of the areas and get the total area of the entire shape. The area of the entire shape is 19 square inches. Oh, I realize this is inches. This is inches. And this is going to be inches cubed. And this one's going to be inches cubed. We're not going to sum up x tilde and y tilde. We can't just add up the centroids. That doesn't take advantage of whether it's a positive value or a negative value. So we don't just add up the centroids, but we do this weighted average. So I have my weighted averages of the x relative to the area. Okay. And we're going to sum those up. And do the same thing over here. And you'll notice that the XA is a negative 22. That means that we're probably going to have an X value on the negative side or on the left-hand side of the Y-axis. And that makes sense. That passes a gut check. All right. So X, and it's a little harder for me to do an X bar here, so we'll do X underlined. This is going to equal the sum of all the X tilde A's divided by the sum of all the A's. Okay. And then we're going to have Y equals, we're going to call that Y bar. And that's going to equal the sum of all the Y tilde A's divided by all the A's. So let's save this. And I'll send it back into my OneNote. There we go. Looking great. And I want to zoom in here for a second. Okay. X. Our total centroid for the entire object is going to be just a little bit past this radius here. And up 1.38, so a little bit above it, but not quite halfway. So this is going to be X bar, Y bar of the entire location, and that equals 1.18 to the left of the Y-axis and 1.39 above the x-axis. All right, so that's all it's going to take. You're just going to be looking up values, seeing how we can get this to match the pieces, and adding them into a spreadsheet. And the biggest part of the work that we're going to do is going to be setting up the areas and the centroids and let the math fall out in the spreadsheet. Just like in integration, we had to set up the area and the centroid, and then the calculation took care of the rest.